Hi from Gabriele. In this video you will understand once again the importance of not using the so-called internal data. That is a topic that appears frequently in this channel, but also on other content of Staticalmo. To cut it short, internal data is easy to obtain, but with such kind of data you can't have useful results. Let's go to see a specific case that inspired this video. This person wanted to take the variables that you see here and create the best formula and ratio of those variables to predict one final number that is the actual variable. Then I wrote down where the data comes from. This job post has one interesting feature for me, that is the language used for asking for a statistical model. Let's go to see the data they provide. You see a decent amount of columns and around 5k rows. Let's go to do some descriptive statistics that will help us to build the model. For the target variable we have just two missing, and those two missing values repeat for all the variables. Now let's check the distribution of the target variable, and it is a almost perfect normal distribution. As a reminder, a normal distribution is something also called bell-shaped, and the data fits this distribution very well. And it is even suspicious, honestly. Then let's go to see the other variables. This is still normal with a shift to the right, same this one, and same the other ones. Ownership is normal with a left-ish shift. Salary, instead, we have something more familiar, that is an exponential distribution. In all honesty, those variables look so neat that I start to think we have fake dataset. But let's ignore this signal. Now, in order to predict this variable, that is the target variable, we have to understand which variables are most correlated with this. We already did the first check to see if we can use the linear correlation with the variables we have, and the answer is yes, because we have almost too much normal distribution. Let's go to see the results of the correlation. This is the target variable, and you see that almost all variables are significant, and you see that because we have p-values below the canonical 0.05. One of the critics of the p-value, the frequentist approach to inferential statistics, is that when you have a high number of rows, as in this case, of course, it is easy to have significativities, and of course this is something to consider. My surprise is that the projected score has a low correlation to the actual score. I expected it to have a much higher value and to lead us to discard it because of the so-called collinearity that I personally have when I see a correlation higher than 0.75. You might notice that we have similar correlations in terms of values, so it is a symptom that the model we can build with such columns won't perform well. Let's go to see the model. As you see, I selected this method that allowed us to build 4 different models with different variables. As you can see, the last model is the one that has only, let's say, significant variables, even though salary is at the limit. With those variables, though, we explain at best 20% of the variability of our target column. Why? Because as anticipated, and as I said multiple times, if you take the so-called internal data, you can't explain much of a phenomenon. And since we deal with a sport, I honestly don't have the experience to suggest external data that can explain this variable. In the case of financial data, I gave some ideas, for example news, but here the news could be seen by the projected score. And you can see that even though it can classify as a misleading variable, the last model doesn't include it. As a conclusion for this video, we have two lessons. Of course, if you have data easy to obtain, you can't have meaningful results. Those are useless models. Second lesson is that in sports, the projected score can actually make you do more money than you can expect. I had more than one case then using just this variable, you could guess correctly the results with an accuracy between 50 and 60%. So it is a profitable strategy. But of course, you could say it is not entertaining because you have average results. It is all for this video. Remember to always seek external data. It's hard to find data when you want to build models of sport results or financial results. Bye and see you the next time.